All right. Um, Welcome to section 4.2. We are going to solve for two equations, two unknowns now, using what we call the substitution method. And you will learn a third way in the next section called the addition-elimination method. And you have just got to figure out which one you like the best and you can use it. In particular situations, substitution is easier than the elimination or graphing and so on and so forth. So you just got to identify which one to use, really. I mean, you can use any that you would like when it comes to tests on the homework. Please follow the directions of how to use the substitution method and the elimination addition method. All right, so with the substitution method, you have to solve for a single variable. So you either have to solve one of the equations for x or for y. And if we look at this first example, equation 2 has x already solved for in terms of everything in terms. So x, I know, is equal to 3y. So I'm going to take 3y, that 3y, and I'm going to plug it into this other equation wherever I see x. So I'm going to start rewriting that first equation. Instead of writing x, I'm going to write 3y, because that's what I know what x is equal to, plus y is equal to 16. 3y plus y equals 4y, which equals 16. Divide by 4, divide by 4, y is equal to 4. All right, so now I need to find out what x is. I can throw this into either into the first equation or the second equation and solve for x. I'm going to put it into the second equation because that looks a little bit easier. So I know that x is equal to 3 times y, and I'm going to replace y with 4. So therefore, x is equal to 12. All right, now, big thing, don't forget to check. So let's go back to the first equation. Check. Okay, so what is x? That's 12 plus y, which is 4. And is that equal to 16? Yes. All right, second equation, x is 12 equal to 3 times 4. Yes. Okay, often the check won't be quite that easy, but always check, okay? Again, here's another example. This time I have the first equation and it's solved for y. So I do not have to solve for my x or y because it's already done for me there in the first equation. I know that y is equal to 3x plus 1. So I'm going to throw the 3x plus 1 in for y into the second equation. So I'm going to start copying the second equation. 3, that's a y. I'm going to pause, put the 3x plus 1 in, minus 4x, and set it equal to 13. Now I'm going to distribute. 3 times 3x gives me 9x plus 3 times 1 minus 4x equals 13. Combine like terms, so 9 minus 4 is 5x plus 3 equals 13 minus 3 minus 3. 5x is equal to 10. Divide by 5. Divide by 5. X is equal to 2. All right. And then the next one, so that's really the hard work. Finding the first variable is the hard work, but the second variable is just as important. So I'm going to use the equation y is equal to 3. I'm going to use the first equation to find y. 3 times 2 plus 1. So y is equal to 6 plus 1. Y is equal to 7. Okay, and I think when you give this answer, you're going to have to do 2, 7 to enter it in as a point, just like you would graphically, because it is set up as a point. All right, now let's check. All right, is 7 equal to 2 times 3 plus 1? 7 is equal to 6 plus 1. That checks. All right, now let's check the next one. 3 times 7 minus 4 times 2, is that equal to 13? Is 21 minus 8 13? I sure hope so. Okay, so that checked out. That tells me I can enter it in as the 0.2 comma 7. All right, my next solution, I've got a slight problem. Neither one of them do I have y equals or x equals. So I have to solve for x or for y. It doesn't really matter, but the first thing I would say is look for one of the equations that has just one x or one y. Whichever one has that, I would work with it. For example, equation 1 has 1x. So we're going to solve for that 1x. So we're going to take x plus 8y and set that equal to 20. Solve for x. So I'm going to subtract 8y, 8y. And then I'm going to have x is equal to negative 8. Oops. Negative 8y plus 20. All right. Because I solved equation 1, I have to throw it into equation 2. So equation 2, I'm going to start off with 4 times, then I'm going to replace x with what I had solved x for in the equation 1, plus 6y equals 2. 4 times negative 8 gives me negative 32y, plus 80 plus 6 equals 2. Oops, 6y. Okay, combine like terms. So negative 32 plus 6 gives me negative 26 plus 80 is equal to 2 minus 80 minus 80. So negative 26y is equal to negative 78. I'm going to go up here at the top. Well, let's see. Okay, now I'm going to divide by negative 26. Divide by negative 26. Note that is a negative and a negative, so that always makes a positive. And that is a positive 3. Okay, if y is equal to positive 3, all right, well, let's go back and throw it in. I'll just throw it into the first equation. X plus 8 times 3 equals 20. X plus 24 equals 20. So x, subtract 24, subtract 24. So x is equal to negative 4. All right, let's check. Is negative 4 plus 8 times 3 equal to 20? Negative 4 plus 24 does equal 20. Check. Does 4 times negative 4 plus 6 times 3 equal 2? 16 plus 18, negative 16 plus 18 does in fact equal negative 2, so that checks. So our solution is negative 4 comma 3. Ooh, look at that gerbledy-gook. Ugh. All right. First thing we're going to want to do is find one with just one variable on either on any of these equations.